universe has always seemed like a place of silent order, stars hanging in the dark, galaxies wheeling in patterns far beyond the scale of our lives. But sometimes something so massive, so overwhelming, moves through that silence that it changes everything we thought we knew. Right now, we are caught in the grip of such a presence, something vast, ancient, and invisible, dragging our entire galaxy through space like a leaf on a black tide. Scientists call it the Great Attractor, but the truth is, we still don't really know what it is. Let's begin with what we do know. We're taught that the universe is expanding, that galaxies are flying apart, carried away by the stretching of space itself. If you imagine the universe as a balloon being inflated, the galaxies are like specks of dust on its surface, drifting farther apart with every breath. And that's true, mostly. But the story doesn't end there. Because gravity, that ancient force, doesn't always listen to the rules. Gravity pulls things together, and in some places, its pull is stronger than the universe's expansion. Where the mass is dense enough, gravity fights back, and it wins. That's why in a universe that's supposed to be drifting apart, we still see galaxies crashing into each other. It's why the Milky Way is on a cosmic collision course with Andromeda, a sister galaxy hurling toward us at over 100 kilometers per second. And it's why scientists have spent decades puzzled by something far more profound. The entire local group, our Milky Way, Andromeda, and dozens of smaller galaxies, is moving. Not just spinning, not just orbiting, it's being dragged. For years, this movement made no sense. Everything around us, galaxies hundreds of millions of light years away, seemed to be shifting in one direction, like leaves caught in a powerful, invisible current. Scientists could measure this flow, but they couldn't explain it. Something was pulling us, but we couldn't see what. Then came a breakthrough, an unsettling discovery buried behind the crowded stars and thick dust of our own Milky Way. There, in a region of space known as the zone of avoidance, a place so shrouded in starlight and cosmic debris that it's nearly impossible to peer through, astronomers found hints of an immense gravitational anomaly. Something was there, and it was enormous. They named it the Great Attractor, but the name didn't bring answers. In fact, it only deepened the mystery. What could possibly be so massive that it pulls not just our galaxy, but thousands of others toward it, against the very expansion of the universe itself? Early estimates placed its mass at over 1,000 trillion times that of our sun. That's enough gravity to bind entire superclusters together. But when scientists looked deeper, even with powerful X-ray telescopes that could pierce the galactic veil, they didn't see nearly enough mass. Yes, there were galaxies in the region, many of them, but not enough to account for the pull. That's when the puzzle started to twist into something stranger. Because behind the Great Attractor, even farther away, about 650 million light-years, lay something even more colossal: the Shapley supercluster, a sprawling, packed conglomeration of galaxies with an estimated mass of 10,000 trillion suns. The gravitational pull from Shapley was staggering. Everything within a billion light-years, including our galaxy, seemed to be falling toward it. The Great Attractor wasn't the end of the mystery, it was just the beginning. And then things got even more strange. While mapping the movement of galaxies toward Shapley, astronomers noticed something that didn't fit. The velocity of our galaxy's motion, the speed at which we are being pulled, didn't add up. Shapley was massive, yes, but even it couldn't explain the full force dragging us through the cosmos. About half the cause of that motion remained unaccounted for. It was as if something was missing, or maybe something was pushing. In 2017, scientists published a groundbreaking study pointing to a new cosmic enigma: the dipole repeller. Located in the opposite direction from the Shapley supercluster, this region of space is curiously underdense. There are fewer galaxies there, fewer stars, fewer anything, and everything nearby seems to be moving away from it. It behaves as if it's repelling matter, not attracting it like the rest of the universe's great structures. Now here's the catch. It's not really pushing in the traditional sense. What appears to be repulsion is actually the result of gravitational imbalance. With so much mass clustered in regions like Shapley, and so little mass in the dipole repeller, Galaxies are naturally pulled toward the denser side, but from our perspective, it looks like something is pushing us away from the repeller, adding fuel to our rush toward Shapley. This illusion of cosmic repulsion sparked a wave of new research, challenging how we understand the structure of the universe. But some scientists aren't so sure it's just an illusion. A few bold voices in astrophysics have begun to whisper of unknown forces, perhaps even physics beyond the standard model. Could there be a repelling force, a kind of dark energy cousin that operates not by pulling, but by pushing? Could the universe have pockets of negative pressure or exotic fields that distort gravity itself? We don't know, and that's both terrifying and beautiful. What we do know is that the Milky Way, our home, is in motion, not drifting, not coasting, but falling. We are being carried by a tide that stretches across hundreds of millions of light years. And what's at the end of that current? A swirling chaos of light and gravity that might not even be the final destination. Meanwhile, other clues are surfacing. Subtle ripples in the structure of the Milky Way stars have led scientists to believe that we've already collided with something. Another galaxy, faint and spread out, called Antlia 2. Hidden behind our galactic disk, Antlia 2 was nearly invisible. Its stars dispersed like smoke. But the scars it left on the Milky Way are undeniable. Waves of stars, ripples in the galactic disk, like the echoes of a past impact. We're not just moving through the universe, we're crashing through it. The scale of these events is unimaginable, and yet here we are, small, brief, human, able to detect the gentle tug of gravity across unfathomable voids. With instruments of glass and silicon and minds full of wonder, we are uncovering a truth that's both humbling and electrifying. Our galaxy is not at rest. It is part of a vast cosmic dance, one that stretches across the grand architecture of the universe. And whether we're being pulled by giants or pushed by phantoms, one thing is certain: the story is far from over. The first time we truly looked beyond the Milky Way, we didn't expect to find chaos. But we did. Galaxies weren't just scattered randomly like grains of sand flung through space. They were part of something much grander. They clung to each other in massive webs, vast sheets, and brilliant nodes of cosmic gravity, separated by even grander voids like the dark, empty silence between thoughts. These structures, these filaments, were not just abstract patterns in space. They told a story of gravity's ancient tug-of-war and of a universe still shaping itself. For a long time, we thought we understood the shape of that story, but now the narrative is shifting fast. When scientists first caught wind that something unusual was happening in our own galactic neighborhood, it came as a shock, because it wasn't just the known laws of gravity pulling on us. There was a disturbance, a ripple, a motion that couldn't be explained by what we could see. The galaxies weren't just moving, they were being pulled by an unknown hand. The Milky Way was not drifting lazily through space. It was in motion, fast and purposeful, like a leaf caught in an invisible current. But what was driving that current? The first clue came from the realization that galaxies near us shared a strange behavior. They were all headed in the same general direction. And that direction pointed not toward empty space, but towards something deeply hidden behind the thick veil of our galaxy's own dust and stars, a place we couldn't see directly. We called it the Great Attractor. At first it sounded almost mythical, something so massive, so gravitationally powerful, that hundreds of thousands of galaxies were flowing toward it. But the deeper astronomers looked, the more real it became. Located about 200 million light-years away in the Norma cluster, it had enough mass, estimated at over a quadrillion suns, to draw in our entire region of the cosmos. Imagine the gravitational pull of a trillion Earths, of a billion suns, and then multiply that. The numbers cease to have meaning. What matters is what they do. They bend reality itself, and they were pulling us. But even as we traced our journey toward this cosmic convergence, another shadow emerged behind it. It wasn't just the Great Attractor tugging on the Milky Way. It was something even bigger. Another mass, even more hidden, but far more dominant, the Shapley supercluster. This enormous congregation of matter lies roughly 650 million light-years away, in the direction beyond the Great Attractor. And it is, in many ways, the true center of gravity in our corner of the universe, a city of galaxies, a traffic jam of matter. Thousands of galaxies packed so densely that space seems to warp under its weight. With a mass that dwarfs the Great Attractor, 10 times more in fact, it quickly became clear that the Shapley supercluster was a major player in our cosmic motion. But here's the strange part. When scientists calculated the gravitational pull from Shapley, even after adding the Great Attractor to the equation, it still didn't make sense. Something was off. Something was missing. The math didn't balance. There was still a large portion of our galaxy's velocity, our motion through space, that couldn't be accounted for. That's when things took a turn. Because instead of another attractor, something massive pulling us, scientists began to suspect the opposite. That part of our motion wasn't being caused by a pull, but a push. It defied every intuition we had. After all, the universe doesn't push, does it? It pulls. That's what gravity does. But in 2017, researchers studying the detailed motion of galaxies made a startling discovery. In the direction exactly opposite to Shapley, there was a region almost completely empty, a vast, underdense volume of space. Few galaxies, fewer stars, a cosmic desert, and everything near it was moving away. They called it the dipole repeller. Not because it was literally repelling galaxies. It wasn't emitting some anti-gravity force, but because its lack of matter meant there was no mass to anchor anything in place. With so much gravity being exerted from the opposite direction, by Shapley and others, the dipole repeller acted like a cosmic void that let everything slip away, faster and faster. In this strange ballet of gravitational forces, emptiness itself had become a player, an absence acting like a presence. So here we are, caught between two giants. On one side, the massive embrace of the Shapley supercluster. On the other, the silent emptiness of the dipole repeller. Pulled and pushed, like a ship caught between two titanic waves. And within that great cosmic tide, the Milky Way is not just drifting, it's colliding. Our galaxy is actively merging, warping, rippling. Just recently, astronomers discovered something even more intimate. They found that the Milky Way itself might have been impacted by a smaller, diffuse galaxy, Antlia 2. It's massive, but ghostly. So diffuse that it escaped detection until only a few years ago, hiding behind the bright haze of our galaxy's center. But the evidence is mounting. Antlia 2 may have already collided with us, its wispy structure and distorted motion suggesting a violent past. The collision would have sent ripples through the Milky Way, distorting its outer edges like tremors in a pond. And this is where things become even more unsettling, because the ripples haven't stopped. They suggest not just one collision, but possibly more. A cosmic history of impacts we're only beginning to uncover. As if our galaxy is still ringing from the echoes of ancient encounters, some recorded in the disarray of our stars, others still hidden in the dark. It raises a deeper question. What does it mean for us to be caught in this motion? What does it mean for our galaxy to be in the midst of a gravitational journey shaped by ancient forces billions of years in the making? We often imagine space as static, stars twinkling in a quiet sky, but it's anything but quiet. The Milky Way is moving at over 600 kilometers per second towards something we still don't fully understand. And here we are, on this little blue dot, orbiting an ordinary star in the suburbs of a galaxy hurtling through a cosmic current. A galaxy shaped by impacts, guided by invisible hands, pulled and pushed by both presence and absence. The sheer scale of it is enough to make you dizzy. But it's also deeply humbling. In a universe filled with unimaginable forces and unfathomable distances, we're beginning to sketch the outlines of our cosmic journey. And though we're far from understanding it all, each discovery feels like a note in a grander symphony, one we've only just begun to hear. We tend to think of galaxies as frozen in time, fixed like constellations painted on the inside of a cosmic dome. But when you peel back that illusion, when you truly look, when you measure, track, and calculate, you see something far more alive, far more dynamic. Our Milky Way isn't a still image. It's a living, shifting creature, shaped by time and torn by gravity. And now we know it is colliding, merging, being consumed, and consuming in return. Perhaps the most dramatic example of this lies just outside our doorstep. Orbiting our galaxy are dozens of smaller satellite galaxies, silent companions in our cosmic dance. Some, like the large and small Magellanic Clouds, are easily visible from the southern hemisphere. But what we've only recently begun to grasp is that they're not just passively orbiting, they're on a direct collision course. The Magellanic Clouds are rich in gas. As they plunge toward the Milky Way, they drag with them enormous streams of hydrogen, twisting behind them like a ghostly comet tail. This stream, invisible to human eyes but bright in radio waves, wraps halfway around the galaxy. It's a wake, a signature of coming violence. And when they finally merge with the Milky Way, roughly 2 to 2.5 billion years from now, they will flood our galaxy with fresh material, ignite new waves of star formation, and potentially trigger gravitational shocks that ripple through the galactic disk. And then there's Andromeda. It's the largest galaxy in our local group, a majestic spiral roughly twice the mass of the Milky Way, hurtling toward us at over 110 kilometers per second. The collision is inevitable. In about 4 billion years, Andromeda and the Milky Way will begin to merge in a spectacular, slow-motion cataclysm. But despite the violence of the term collision, this won't be an explosion. It'll be more like a gravitational dance. Stars separated by such immense distances will rarely collide directly. Instead, gravity will distort both galaxies, stretching and twisting them, pulling long tidal tails of stars and gas into interstellar bridges. Over time, the two galaxies will lose their spiral shapes, falling together again and again like dancers in a slow embrace, until they eventually settle into something new, a single massive elliptical galaxy. Astronomers already have a name for it: Milky Way. But the question remains, why does this matter now, today? Because the signs of this merging, this consuming, this becoming, are not just theoretical, they are written into our sky right now. In 2022, researchers used data from the Gaia Space Telescope to map the motion of more than 1 billion stars in our galaxy. What they found was extraordinary: evidence of long-forgotten mergers preserved in the orbits of stars. Giant, invisible scars left behind by ancient galaxies that were torn apart and devoured by the Milky Way. One of those is the Gaia sausage Enceladus, a strange name for what was once a galaxy all its own, now shattered and spread across the Milky Way's halo like cosmic breadcrumbs. It collided with the Milky Way around 8 to 10 billion years ago, delivering not just stars, but entire clusters, dark matter, and momentum. Its remnants are still with us. They are us. Many of the stars in our night sky, including some in the solar neighborhood, are survivors of that ancient impact. So when we talk about our galaxy colliding with something massive, it's not just in the future. It's happening now. It has always been happening. The Milky Way is not a single pristine object. It is a patchwork of ancient mergers, each leaving behind traces in the motion of stars, the shape of the disk, the warp of its arms. It is a record of cosmic violence, still unfolding. Even more startling is what lies beyond our immediate galactic future. After the merger with Andromeda and the absorption of smaller galaxies like the Magellanic Clouds, the newly formed Milky Way will continue its motion, still being drawn toward the Shapley supercluster. But by then, the universe itself will have changed dramatically. Dark energy, the mysterious force accelerating the expansion of the universe, will continue to push galaxies away from one another. Most galaxies we see today, millions, billions, will vanish from view entirely as the fabric of space stretches them beyond our cosmic horizon. Only Milky Way and the few remnants of the local group will remain visible. It will be an island in an ocean of darkness, a galaxy built from the bones of many, and it will still be moving. What makes this even more haunting is the perspective it gives us. Right now, we are in a rare moment in cosmic history, one where the sky is filled with other galaxies, where we can still piece together the story of the universe's birth, its expansion, and its future. But this window is closing. Future civilizations, if they arise, may see only the stars of Milky Way and the cold relics of their own local space. They may never know there were once trillions of galaxies beyond their reach. They may never know the truth we've just begun to grasp, that galaxies grow through collision, through absorption, through an endless cycle of cosmic transformation. And so, standing here on Earth, orbiting an ordinary star in a galaxy in motion, we are witnesses to a drama far older than our planet and far bigger than our comprehension. The Milky Way is not finished. It is still being shaped, still being pulled, still being collided into. It is a galaxy on a journey, not just through space, but through time, evolution, and eventual rebirth. It's easy to feel small in all this, to feel insignificant in the face of these vast forces. But perhaps the opposite is true. Perhaps the very fact that we can understand any of it, that we can measure, simulate, and feel awe, is evidence that we are not just passengers. We are participants. We are the consciousness of the galaxy awakening to its own history. We are the only known beings in this corner of the universe who can look up and realize that our galaxy is colliding with something massive and understand what that means. And that in itself is extraordinary.